Swayam Prabha. Digital India. Educated India.
Hello everybody, welcome to my next lecture, where we are going to study again the reactions of carbenes. We have started that addition reactions. Among there are three type of actually reactions we will study for carbenes. One is this addition reactions, insertion reaction and the rearrangement reaction. Now, we are actually studying the addition reactions. In the last class, we have already discussed about the addition reaction of alkene with a carbene, and we have mentioned this addition is depending on the nature of the carbenes. As per example, if we take singlet carbene, it will give certain type of reactions. If it triplet carbene, it will give another type of reactions. There we have studied that singlet carbene, how they have reacted with the alkenes, and we found that the addition of these singlet carbenes work in a concerted manner and their reactions are highly stereospecific in nature. So, today we will learn the additions of triplet carbenes towards alkene. So, addition of triplet carbene towards alkene. Okay. So, how will they react? Like previous class, again we can take this Z olefin. Okay. Now, if we have this triplet carbene, for better understanding I can draw in this way, which we can actually, this is the triplet carbene. So, in bracket we can write the triplet carbene, okay. And in general we have previously mentioned that their behaviors are some kind of like diradical. Okay. So, now this triplet carbene, how they will react with the olefin. So, if it reacts with this olefin, initially it will generate this type of intermediate. So, something like this. Okay. Now, it can go for this slow step, that is the slow spin flipping, okay. Otherwise it cannot make bond, okay. Both are having in similar type of spin. So, they cannot, if you see they are similar type of spin, okay. So, they cannot make bond. So, the spin flipping is required, fine. Now, once the slow spin flipping is happening, then it actually gives okay, this electron that can give the spin flipping. Okay. So, now they are having the opposite spin, okay. They are having opposite spin. Now, they can make the carbon carbon bond. So, this is the first step and they can make carbon carbon bond formation. Okay. Once they can make the carbon carbon bond form, or once they can generate that carbon carbon bond, actually we will get our desired cyclopropane ring. But here again we will get the cyclopropane ring with the similar stereochemistry like the starting material. So, the overall geometry preserved here. But the interesting thing is that as this is going in this type of steps, so there is enough time opportunity that this particular intermediate that can go or proceed through this free carbon carbon bond rotation. This is a single bond, carbon carbon bond. Now, it can rotate itself. So, free carbon carbon bond rotations. Okay. So, once this will happen, then obviously the geometry will be scrambled as per example here it is like this. Okay. So, something like this. Okay. Once it will form this one, then again to prepare this cyclopropane ring, they have to make this carbon carbon bond here. For that again this spin flipping is required. Okay. So, the spin flipping will work in this way. Okay. This spin flipping will work and give you the here okay. If the spin flipping happens, then obviously this will work like, let us say like this, and then these two can make bond and this first process, that is the carbon carbon bond formation. Okay. That will give our desired cyclopropane ring, but with a different stereochemistry. Okay. So, if you see here that in case of singlet carbene only single product form. Okay. So, preserving the stereochemistry, but in this case there is a scrambling of the stereochemistry. Here I would like to mention that this spin flipping that generally occurs through the collisions with another molecule. In general in the reactions there will be solvent. So, with the solvent molecule if it collides, then only it can go for the spin flipping. Okay. So, once this spin flipping happens, then only it can make this carbon carbon bond. Okay. So, addition of this triplet carbene towards alkene, we can call these reactions as stereoselective. Okay. So, here stereochemistry of the starting material has been scrambled and the rotation in the intermediate through this carbon carbon bond triggers this kind of scrambling of the stereochemistry here, and that gives these two different products. Here it is happening, this one is major product in the reactions and here it is the minor product in the reactions, but here obviously we are getting the mixture of two product. Okay. Even though we are starting from one particular stereochemistry, that means we are taking one olefin Z olefin, but we are ending up getting two different cyclopropane product, that is one is cis, another one is trans. Fine. As per example, we can see if we photochemically irradiate these diazo compounds, then that can generate the carbenes, and what we found in the product that this is Z. In the product it generates that cyclopropane like this plus okay. So, this is around 65% and this is around 35%. So, from this outcome of these reactions we can suggest that definitely the carbene that generated by this photochemical irradiation of these diazo compounds is actually generating triplet carbene. Okay. So, what we have initially suggested that these chemically we can prove that the nature of this carbene through these addition reactions. Okay. Next we will see during the addition of these concerted reactions via this singlet carbene through orbital symmetry approach. Okay. So, let us see how does it work these 1 plus 2 cycloaddition reactions of this of singlet carbene. Okay. So, before that we know that in general the alkenes, if we draw its orbitals, we see that so here this is the HOMO and this is the LUMO. Okay. So, LUMO means lowest unoccupied molecular orbital and HOMO means highest occupied molecular orbital. Okay. So, for this pi 2 system, so this is the pi 2 system, this should be its orbital molecular orbitals. Okay. Now, if we take alkene HOMO, because we are reacting with a olefin having pi 2 electron system with a carbene. Okay, fine. So, let us draw its orbital, let us check its orbital symmetry. So, we have taken this Z olefin and so this is the alkene HOMO. So, this is alkene HOMO. Okay. Now, we will see the carbenes LUMO, because the alkene HOMO will react with the carbene LUMO. So, if we see the carbene LUMO, so this is the carbene LUMO where this empty p orbital is there. So, this is the empty p orbital and this is the filled pi orbital. Okay. So, in this case the empty p orbital, that is the carbene LUMO. So, this is the, we can draw like here. So, this is carbene LUMO. So, alkene's highest occupied molecular orbital is this, we have drawn over here like this way, and this is the carbene's lowest unoccupied molecular orbital. Okay. So, now if we see that how they can generate this bonding, let us say if we check, it is nicely making bonding interaction. Okay. But we want to make like this, definitely this is not giving the bonding interactions, rather this is giving the anti-bonding interactions. Okay. So, this is the bonding interaction, and this is the anti-bonding interaction. Okay. So, in this way, definitely through this direct approach of, in this direct approach we cannot make complete bonding. So, definitely this type of approach is not happening. Now, if we take in opposite way, here we have taken alkene HOMO and carbene LUMO. Let us take the opposite one, that means we will take the alkene LUMO and carbene HOMO. Okay. So, let us draw this alkene LUMO. Here already we have drawn that. Okay. Now, filled up. So, here we can like this. So, this is the alkene LUMO. Now, we will draw the carbene HOMO. Okay. Now, let us check how this is the filled sp2 and this is the empty pi star orbital. Okay. So, here this filled sp2 orbital, that is acting for the carbene as highest occupied molecular orbital, and in case of alkene the lowest unoccupied molecular orbital is this empty pi star. Fine. Let us check whether their bonding is, if you see this one, this is nicely giving the bonding interaction. Okay. But this one is anti-bonding interaction. Okay. So, this is the anti-bonding interaction. Fine. So, in this case also, if we see that these two direct approach are not possible for this type of cycloadditions with singlet carbene. So, here we can mention that direct approach for this singlet carbene is impossible, because if we see that this is giving some anti-bonding interaction through this direct approach. Okay. So, this is not possible, but the reactions are happening. So, how these reactions are actually working, that we will see now. Okay. So, let us have a look the sideway approach of carbene towards alkene. So, now we will learn the side way approach of carbene towards alkene. Okay. So, direct approach does not work for this addition of this carbene towards the olefin. Okay. So, orbital symmetry is not approving that. So, let us see that how the sideway approach is working. So, here if we see again we will take the alkene HOMO, okay, and carbene LUMO. So, we will draw that again. Okay. So, we have taken this Z olefin. Okay. Now, its HOMO means okay. So, this is the corresponding olefin's highest occupied molecular orbital. Now, we will see its LUMO, that means the empty p orbital, that we will see. We have seen when it is directly approaching in my previous slide or previous slide, we have seen that when it is directly approaching, this is not giving the bonding interactions. So, that becomes impossible. Now, we will see the side approach of this particular empty p orbital. So, here it is. Okay. So, this is the p orbital of this carbene. So, this is the empty p orbital and this is the filled pi orbital. Fine. Now, if we say that the sideway approach, it is nicely giving this bonding interaction. Okay. So, both way it is giving the corresponding bonding interaction, here also bonding interaction, here also bonding interaction. Fine. So, in this way actually the alkene HOMO and the carbene LUMO, if the sideway approach can be considered, then definitely this orbital symmetry is happening. Okay. And in this way these reactions can nicely takes place. Now, we will check in opposite direction. We have checked previously also in two different way, that taking alkene HOMO and carbene LUMO as well as carbene HOMO and alkyl LUMO, but that does not work, okay, because these are giving the antibonding interaction. But here in the sideway approach of this carbene towards alkene, what we found, this alkene HOMO is nicely making these bonding interactions with the carbene LUMO. Let us see the opposite way. That means, now we will take the alkene LUMO and carbene HOMO. That means, now we will take the alkene LUMO, that means lowest unoccupied molecular orbital. You see, so like this pi 2 electron system. So, you can fill up like this, something like this. Okay. So, here this will be HOMO and this will be LUMO, we have shown previously also. So, in this case this is the alkene LUMO, we will draw. Okay. Let's Okay. We will take the corresponding alkene LUMO, that is this. So, this is the LUMO, means this is the empty pi star, and we will take the corresponding carbene HOMO, that is this one. So, the filled up now we will check its interaction, here also bonding interaction and here also bonding interactions. Okay. So, this is the bonding interaction and here also the bonding interaction. Okay. So, both the cases. Okay. So, here we have taken the sp2 filled orbital and this is the empty pi star orbital, and this has been considered as alkene LUMO, and this sp2 filled, that is the carbene HOMO. So, in this case both the sideway approach are actually giving the interpretations that how these carbenes are actually reacting with the alkenes. Okay. If we see this cyclopropane product, they are almost tetrahedral arrangements they are having, and if we see that they are reactions, they are actually starting from like this. So, it is Z. So, if you see these carbenes, okay. So, in general how they are reacting, okay. So, okay. So, the hydrogen atom swings round into place. So, hydrogen atoms that swings, okay, to give this tetrahedral type of arrangement, and finally, that gives this cyclopropane ring with this stereochemistry. Okay. So, this is the overall approaches, the direct approach, sideway approach, that shows that where these bonding interactions are happening, where not, and this way we can actually interpret that how these 1+2 cycloadditions for the singlet carbenes happening in this concerted manner, and how their stereospecific reactions happening with this type of singlet carbenes. Thank you very much.